Welcome back, Algebra Express. We are in Rockswold 3.2. So we're going to talk a little bit more about quadratic equations and problem solving. And we'll talk a little bit about the zeros of the graph and what those look like. And they start you off here with a student activity, equations, zeros, and graphs. So they start you off with this quadratic equation. Solve the quadratic equation by factoring. So this should be a sort of review of the things that you've done already. So if we look at x squared minus 4x plus 3, you can try to find your magic numbers, but we're multiplying something to 3, adding to a minus 4. We're going to get a minus 4 by making them both negative. And so you should be able to factor these things hopefully by now, but it should look like x minus when we factor that left side. And then this is equal to, and so the two factors of this thing look like x minus 1 and x minus 3. This thing, x minus 0. They are a positive 3. So you might start noticing like certain patterns with the factors look like x minus some number. When we solve and use the zero product rule, it's going to look like x equals to that number. So the solutions are okay. And now if instead of having this quadratic equation equal to 0, if they just talk about this quadratic equation as a function, f of x, they want us to evaluate these things. So what we're saying and what this notation sort of means is that when I go and plug in 1, so like f of 1, if I do 1 squared minus 4 times 1 plus, that should be 0 when I evaluate it, or f of 1. The other thing is f of 3. Plug in 3. Do 3 squared minus 4 times 3. This should also be giving me 0. And this is my x value. This is the correlating y value. So I could also put this as the point like 1, 0 and 3, 0 if I really wanted to do it in different forms. So this means that 1 and 3 are zeros of my f of x. And we're talking about x equals 1 and x equals 3. These are the two zeros. Look at this graph. What are my intercepts? And so I wrote them up there previously, but my intercepts are the points 1, 0 and 3, 0. So again, they're trying to drive home this sort of notation and vocabulary. If we talk about zeros of the graph, what we're talking about are the x-intercepts. What we're talking about is if we take that function and set it equal to 0 and find the correlating x values. So this is a quadratic. We're expecting to find two solutions. And so when we find two solutions, we're talking about two x values. And maybe also note that we're talking about two real solutions on this one. We found two real numbers. So now they want us to solve this thing graphically. So if I'm being honest, I would probably never solve this thing graphically. I prefer to solve things symbolically. Doing things graphically can be kind of deceptive. So on this one, if you want to make a table, that's a good way to go about it. You can make a table. And I picked a few x and y values. So if I do what, -3, I'm going to get 7. If I plug in -2, I'm going to get 0. That's an important one. 1 minus 9 is the vertex. 4, 0. And we get like something 5, 7. And then okay, so our solution set for this, so if we're setting this thing equal to 0, I think what they're trying to get at with this problem is that if we talk about setting this equation equal to 0, what we're talking about is like this is like our y equals 0 line. And this is like our x squared minus 2x minus 8. So what we're talking about is sort of where these two things intersect. Is also known as my x-intercepts. So what we're asking is for the x value on your x-intercept. So that would be x equals a -2 and 4. These are also the x-intercepts. They're the real zeros of the function. So if we're talking about zeros of the function, we're talking about where the y is equal to 0, we're talking about the x-intercepts of that function. Okay, so there is a sort of way to do this if you have technology. So I think I'm going to do a screen share with my TI Smart View. And so if you're on your calculator and you have a TI or something of the like, and you want to put in your function, you're going to hit the y equals. And so I hit the y equals, I type in my function, I type in x squared minus 2x. So I already have my function in here. So you type in your function. You don't want to put anything else in. So you make sure you have your function plotted in y1. You go second quit to exit out of that. So I want to look at my graph. And so this is a graph of my function. So if I want to find the x-intercepts, I go to second and I hit this trace button. So there's my calc. I believe I go to, there's my zeros. There's an option to find your zeros. So if you want to go to your left bound, you go to the left of the 0, and then you go to the right of the 0, and then you guess somewhere in between. So that is giving you a -2. We can do the same thing to find the other number. We can go to second calc. We can find the zeros of the graph. Left bound, right bound, and a guess in between gives me the 4. The other thing I said was what you can also find the minimum there. So if you want to find your vertex, you can also find the vertex of the graph, which would be what? 1 minus 9, I believe is what I found. Come on. There we go. It's a little bit off from 1, but it's 1. 0.99 repeating is 1. Okay, so that is that. Let me stop the share. Okay. So back to this problem. If we want to talk about intercepts and zeros. So if we're talking about a parabola and we're talking about how it can intersect this line, we're talking about a line in a parabola. So let's look at maybe all the different ways that line can intersect. So have a parabola that looks sort of like that, it's going to intersect it twice. We've had two examples like that. So those are if you're getting two real solutions, you can get two numbers. So in this previous problem, it was what? -2, 0, and 4, 0. So if we get two solutions, good. We know what that looks like. So another way we can intersect, a parabola can intersect a line, is we can come and we can hit it just once, right? At that vertex point. So it could intersect it twice, it could intersect it once. And if you remember your solutions, this is like we could have two solutions. We'll talk about what this is maybe in a second. But the other option is you have a parabola and it never intersects your axis. So what does that mean? Probably going to be something like no solution. So these are the three basic pictures that they draw. And if we want to think about the number of real zeros, there's going to be two real zeros. So we've had a few examples like that. This is going to be one point that it hits it at. So this is going to be one real zero. So what's happening here? How are we getting only one solution? And when we got one solution previously, this was repeated. So this is a repeat. So we're expecting two solutions. We're only getting one solution. That's that repeated real zero. Number of real zeros here. So we're expecting two solutions, two real solutions. If we don't hit the axis, those we're not getting any real solutions. So there are zero real solutions. So if there are zero real solutions and we're expecting two solutions, what does that mean? It means the solutions were imaginary. So they don't really say that, but power of deduction, right? We're expecting two solutions. We don't get any. This would be those solutions that look like imaginary numbers. So again, we're on the real number line. And if we're expecting solutions on the real number line and we're not getting them, then those solutions are imaginary. So now we're thinking about the sign of the discriminant and the types of solutions we got. So this is sort of from the last time, but if we're getting two real zeros, the discriminant is the thing that is inside your square root. So we have some number here, we have some number here, but we're talking about this thing right in here. So we want to think about whether it's positive, negative, or zero. So if we're thinking about this, if I'm adding and subtracting and getting two real solutions, the thing in the square root, if it's negative, it's going to be imaginary. If it's zero, we'll talk about that in a second. But this should be the positive one. So your discriminant here is positive. And again, if you want to get some examples on why this is, the discriminant is that big thing in the square root. Minus 4. It's the thing in your square root in the quadratic formula. So if you want to think about just doing the numbers 5 plus or minus, throwing in numbers for A and B, it doesn't really matter. What we're concerned with is the sign of the thing. If I do a positive versus if I do the same thing versus if I do the same thing. I'm saying, does it matter whether it's positive, negative, or zero? What are your solutions going to look like? And so we have talked about this before. Now we're trying to go kind of the other way, right? If we get two real zeros, then our discriminant was positive. If we're getting that one real zero, this is the repeat. So in order for it to repeat the sign of the discriminant, maybe it's really kind of bad to say the sign because it's zero in this case, right? It's not positive or negative. Your discriminant is zero. The sign here, in order for it to be imaginary, you would have to be getting negatives in that square root. Okay, so next page. We have an application problem. So this one, I think the hard part is probably going to be the setup for most people. So this problem says a rectangular picture frame has outer dimensions 24 by 28 inside the frame, 320 square inches of picture shown. Find the width of the frame surrounding the picture. What they're saying. So they give us this picture. And in order to get the area, we're going to have to find this length by this width, right? Finding area of a rectangle is length times width. Okay, so if we want to find what this dimension is, so I'm looking along here, I see this whole thing is 24, and I see that I have a width of the frame right here. So the width of the frame is the thing that I actually want to find. That's the thing that they're asking for. It's the thing I don't know. So if I want to let this be something, I could let this be X. So I know my area is my length times my width. I'm trying to find my length. I'm trying to find my width. I know my area, and they're giving me the area of the inside is 320. But I need to find the length and the width of the inside. So what I'm talking about, trying to grab another color here. What I'm talking about is this inner length and this right here. It correlates these. So I know this thing, this entire thing is 24, but it also has a width of the frame right here. So I'm going to let that be X. It's the thing I don't know. It's the thing I want to find out. So if I'm looking at this thing, getting fuzzy right quick. So this is X, but I also have another one right here. If I want to know, I should call this one should be the width. This one should be the width. This one should be the length. It's a little longer. Doesn't really make sense. My width should look like 24, but I have to subtract this and I have to subtract this. I'm subtracting 2x from this thing. So minus x, or minus 2x. So this would be my width. My length is this 28, and I have a simple sort of thing happening here. So if I'm looking along here, this whole thing is 28. So if I look along here and along here, I have the width of the frame twice. So I have the 28, and I also have to subtract 2x. So now I'm looking at this thing. This is the setup right here. So we know the inner area is 320 inches squared. We know that this dimension is going to be 28, and I'm subtracting x twice. And this dimension is going to be 24 with x being subtracted twice. Okay, so now I have the setup. The setup is there. I think this is probably the first or the big part of getting this thing together. So you should know the area of a rectangle is length times width. So the entire thing is 24. If we want to get to the inner one, we're subtracting the frame twice. The frame is the thing I don't know, so I'm letting that be x. So I should probably define my variables if I'm doing proper math over here. So x is the width of the frame. So I'm looking at this thing. So in order to solve this, you might want to just like say, oh, I could subtract the 320 or something. We can only do the zero product rule if we set one side equal to 0. So this is probably the furthest from being solved that something can be. We have to do some distribution before we do some factoring. So 28 times 24 is going to give me 672. 72. Then I want to do 1, 2 times 28 is minus 56. X. Now do like minus 48x. Then doing plus 4x squared. So these are not the prettiest numbers, but 672, and we have to subtract 320 from both sides. So if I subtract 320, the 672 minus 320 is going to give me 352. I can do 56 and 48 is going to give me 104. So I can clean this up a little bit. I probably want to rearrange things so that I have my 4x squared minus 104x plus b52 is equal to 0. I think everything should be divisible by 4. So I can divide everything by 4 or factor out of 4, either way you want to do it. But 0 divided by 4 is just going to give me 4. So if I got a constant factor, I can just kind of divide those things out. If it's got a variable, I do have to account for it. So this is x squared minus 26x when I divide that by 4. And this is plus 88. And this is equal to 0. And so I'm looking at factors of 88 that are going to add to minus 26. Okay. So I believe the two factors are going to be 4 and 22. And if they're going to add to minus 26, then they both have to be negative. So this, I can use my little shortcut on this thing. So instead of breaking that middle term apart, I can kind of just jump to these factors. And then I'm still solving x minus 4 is equal to 0 or x minus 22 is equal to 0. So I'm getting is x equals to 4 or x equals to 22. When we're talking about inches here. Okay, so now I have two possible solutions. So I'm looking at this thing. And it's either 4 or 22. So if I'm looking at 4, this would make it 4 and 8 inches. And if this is 8 inches, this would be what? 24 minus 8 would be 16. Okay. And so if I have something that's 16 and I subtract, what, 8 from that, 16 by 20 is going to give me the 320 inches squared. So that looks like it's working out. So x equals 4 looks like a good solution. If I'm looking at this x equals 22, if this is 22 and this is 22, oh God, that's already 44 inches. So there's no way that's possible. This side is only 24 inches and this side's only 28 inches. So this one is not a good solution. This is an extraneous solution. So you should get this, but then you should, when you go back and look at the problem, you should say there's no way in heck this is happening, and you should reject it. Put a big line, say it's extraneous. Show something to say that you're rejecting that. Do not accept that as a solution, right? This guy, he's good. Okay, so the next problem. We want to start solving for y. They're going to start solving for letters, what they're saying. So y squared equals 4x So this is going back to the previous chapter with the square root property. So previously we were solving, but now we're solving for y. So if we want to solve for y, guess what we have to do? We have to take the square root. The y squared equal to 4x. I have to take the square root of this, and I have to take the square root of this. And if I'm solving for this, I have to, anytime I take a square root and this thing is being squared, I have to do a plus or minus. So y is equal to plus or minus, root 4x. Okay, so I can simplify this a little bit. I can pull out the root 4. Y equals plus or minus. Root 4 is going to give me 2 when I pull it out, but the x is still going to stay underneath the radical. So we're solving for y. Y had a square root. We had to put a plus or minus anytime we take a square root. Or y was being squared, so we had to take a square root. And then we could simplify this a little bit. But the next thing they ask is this relation a function? So, what does the function mean again? So I want to try plugging in x equals 1. So if I plug in x equals 1, I plug it into this function. The first thing I'm going to look at is plus 2 root 1. Plus 2 root 1 is going to give me positive 2. The other thing I can do is plug in 1, and it's going to also give me a negative 2. So we talked about this in a few different formats of what a function is or what a function looks like. But this thing is definitely not a function. And part of that is because when I plug in 1, I can get 2 different solutions. So when I plug in something, I only want to get 1 solution out of it. So I'm getting same x with 2 different y's. So not a function. Oh no. Looks like my pin's going up. Let me see if this will work. All right, not a function. My pin did not function on not a function. Solve for y. So we're solving this thing for y. This is the thing we want to isolate and get by itself. So this might look a little funky, but the operation here is plus or minus with this crazy thing. So we hadn't talked about this, but this is actually the function for a circle. So if we were to graph this thing, it would look like a circle. It would be at 1, negative 2 would be the center, and then the radius would be 3. So anyway, that's not what you're asking. But if we want to solve this thing, y plus 2 squared is going to equal to, I believe we have something like 9, and we have minus this thing, x minus 1 squared. So we're subtracting this thing over. Now we have something that looks like y plus 2 squared. We want to use the square root property. We want to get the thing that's being squared by itself. So now that we have this thing by itself, square root. So if we square this, square root this, we have to put plus or minus on the square root variable. When we take a square root to solve for a variable, have to put that plus or minus. This looks like root of 9 minus x minus 1 squared. You might want to try to clean this thing up somehow. I'm not sure how you're going to do that. But if this is 9 times x minus 1 squared, you probably could. But there's this subtraction sign right here that really makes things difficult to clean up. So if everything was being multiplied in here, you'd be okay to clean some stuff up, right? But we have addition subtraction that separates terms. So we have different terms underneath the square root. This is one term and this is like another. We can't start simplifying things out across terms. So if that was multiplication, you'd be okay, but it's not. So don't try to simplify things there. I think the best thing we can do is subtract 2 from both sides to solve from y. But y equals like a minus 2 plus or minus root 9 minus x minus 1 squared. So this is the best that we can sort of do with this thing. And if we're looking at this thing, the next question they ask, is this relation a function? So you can try to plug in a value for x and see how many values it's going to give you for y. But if we have a plus or minus sign in our solution here, anything we plug in for x, one of them is going to be plus that thing, and then one of them is going to be minus. So we're going to get 2 solutions for any x that we plug in. So a good indicator that you don't have a function is actually this plus or minus sign. So this is not a function. And a good indicator that also that this isn't a function is I told you this was a circle, right? So if you draw a circle, it's not going to pass your vertical line test. Okay, so we should be able to solve for a single letter is what they're trying to do. The Pythagorean theorem looks like a squared plus b squared equals c squared. You're relating the lengths of the sides of the right triangle to the hypotenuse c. So A and B are the legs, C is the hypotenuse. Solve the equation for the length of one leg A. So we want to solve for A. So we look here at A. So I look A squared, further out it's being added to B squared. So the first thing we want to do is subtract a B squared from both sides. So A squared is equal to C squared minus B squared. We want to solve for A. A is being squared, so this is the square root property. And anytime we take a square root, we have to take a plus or minus. So if we want to get A by itself, A should be equal to plus or minus C squared minus B squared. Okay, so this might be a little silly. If you told me this, I would be okay. I don't this, but there's a little bit of inference that you can kind of take from this, is that A is always going to be a positive number. So now if we think about this a little more in relation to what it's actually doing in reality, since this is always a positive number, you can actually just leave off the negative part of that. A is never going to be a negative number. The thing in the square root's never going to come out to be a negative number. Your hypotenuse should always be larger than your leg. So if you wanted to drop the negative sign, you can just tell me the positive square root. And that's coming from context, right? Mathematically, we should probably always put the plus or minus. Okay. So you might be looking at this thing, the c squared minus b squared. That is a difference of squares. We could convert it to what? C plus b, c minus b. Right? But it's not going to be the same. They're going to be different. That's not really possible. But if you got it, it's a good thing to think. You can start factoring things, see if they come out. That's a good sort of strategy to start going towards. Okay. Square root, we're going to do squared minus b squared. Okay, so now they're giving us a bit of a mixed practice. So we've done a few different things. We've done square root properties, we've done factoring, and we've worked our way up to the quadratic formula. So the square root property. So they talk about the square root property. They give you a short little example here. If x minus 6 squared is equal to 16, what we can do is square root of both sides of x minus 6 squared. X on the side. two options, either x minus 6 is a minus 4 or x minus 6 is a positive 4. And if I add 6 to both sides, either x is equal to minus 4 plus 6 is 2. And 6 plus 4 is 10. So this is a square root property. This is one of the last things we went over. So hopefully this one's still fresh. Square. So that's the thing we talked about, but we're not really going to go into too much. Factoring. So if you can factor something, try to factor it. So these are the sort of steps that you should probably look at. You don't want to like try to multiply this thing through and then subtract the 16 and set it equal to 0 and do that. So if it's set up for the square root property or something super obvious like that, go for it. If you can pull out a GCF and it factors it completely, go for it. So if you can do any of these sort of simpler sort of things, or you notice it fits one of these specific sort of patterns, like the square root property, go for that. Do your square root property, do your GCF. If those don't work, we can always do factoring in the AC method. Or not always, but we could try factoring the AC method next, right? We can look at this thing, we can see if it factors. If it doesn't factor, the next thing, the thing that will always work is the quadratic formula. And so they give us an example for factoring. So if we want to factor this thing, it looks like x squared. We're going to subtract the 8x over plus 7 to make this equal to 0. And I believe if we factor this, this should factor into x minus 7 and x minus 1. So x is equal to 7 or x is equal to 1. And I skipped maybe a little step in there. Set them equal to 0. Going a little fast. But there we go. You should be able to factor it. You should use your zero product rule and be able to find your solutions. And if we take the solution, plug it back into this equation, it should make it true. Okay, so we did a square root property, we did factoring, and the last thing is the quadratic formula. So if we look at this thing, first thing we're going to do is do some distribution and put it in the right format to do it. So 2x squared plus 4x equal to 1, so I have to subtract 1. 2x squared plus 4x minus 1 is equal to 0. So if I try to find a magic number, I try to find a magic number that multiplies the minus 2 and adds to 4. The 1 and 2 are the only factors of minus 2, with either that being negative or that being negative, and there's no way they're going to add to 4. So there's no way I'm going to factor this thing. Previously, we would have said this thing is prime. Now that we have a quadratic formula, guess what? You should not be using that prime word anymore. So hopefully that's out of your vocabulary. So we cannot factor this. So I want to look at A, I want to look at my B, and I want to look at my C. So my A is 2, my B is 4, and my C is a minus 1. So now we do our little song and dance. We do x equals a negative B. There it is right there. Plus or minus the square root of B squared minus 4AC all over 2A. So you should write this out. I'm probably going to be lazy and not write it out again, since they have it right there. X equals a negative B looks like a minus 4 plus or minus B squared looks like 4 squared minus 4 times A, which is 2, times C, which is a minus 1. And this is all over 2 times A, which is 2 times 2. This is equal to minus 4 plus or minus, I'm going to do 16. Here I have 2 negatives. Overall is going to make this positive. 4 times 2 is going to give me 8 over 4. Okay, yeah. 6 minus 4 plus or minus, I can add 16 and 8 is going to give me what? 24 over 4. I can clean this up a little bit. So if I want to think about root 24 is what? Root 4 and 6 I think are going to be the ideal things to go for. Plus or minus. And I can do root 4, root 6 to clean this up. So root 4 is really 2 root 6 over 4. And now I'm looking at this thing, I can separate this thing. So I can separate this thing into minus 4 over 4 plus or minus 2 root 6 over 4. So if I'm looking along here, this is a minus 1 here. I have a plus or minus. And I can clean this up. This I can divide by 2. And this I can divide by 2. So this is going to look like root 6 over 2. And that's my final solution after I do the quadratic. Okay, and so they give us one last page. So this is a sort of mixed practice page. Choose a method to solve a quadratic equation. So we want to look at different quadratic equations and solve them in kind of the best or most efficient way sort of possible. So they give you a sort of mixed practice page. So number 10, so this is a student activity. So hopefully you're looking at these and trying to do them before I get to them. So number 10 says list the equations for which the square root property would work in their current form. So without doing completing the square. So what is set up for a square root property is what they're asking in that first one. Okay, so the first thing they're asking for is to look for the square root properties, or the ones that look like they're set up for square root properties. So we're looking along here, we're looking for things that just have squares or square terms. So this has something being squared by itself. This thing, and it's got an x term, but this thing has something being squared by itself. Which else? This one. So I think those three are the three that you can solve with the square root property. And so let's go ahead and solve them right quick. So x minus 5 squared equals 8. So if we take the square root of both sides, x minus 5 is going to equal to plus or minus the square root of 8. And the last thing we're going to do is what? Add 5 to both sides. So 5 plus or minus the square root of 8. We can simplify, I believe, is 2 root 2. 2 squared is 4 times 2 will give you the 8. We have 6 equals 2x squared. So this is almost set up to do a square root. The first thing we have to do is get this square by itself. It's not quite by itself because it's being multiplied by 2. So the first step is to divide each side by 2. If we divide each side by 2, we get 3 equals x squared. And guess what? X is going to be plus or minus the square root of 3. And the last square root property problem that we have looks like 2x plus 7 squared minus 5 equals 0. So the first thing you're going to want to do is get that squared term by itself. So we're going to want to add the 5 to both sides. So 2x plus 7 squared is equal to 5. Now that we got the square by itself, we can take the square root, so 2x plus 7. And I'm taking a square root of plus or minus square root of 5. And so now I'm solving this thing for x. I have to subtract 7, so 2x is equal to minus 7 plus or minus radical 5. And now I have to divide by 2, so minus 7 halves plus or minus radical 5 over 2. Okay, so we got those three out of the way. The next one, they say find an equation that can be solved by factoring and solve the equation. So we're looking along here. And I want something that multiplies to 14 and adds to minus 5. So you might be thinking 1 and 14, 1, 2 and 7, 3, 4, 5. Nope. 1 and 14, 2 and 7, if they're going to add to minus 5, but multiply to positive 14. So you're thinking 2 and 7, but there's really no combination of positives or negatives that are going to make it add to minus 7. So right away, this one cannot be factored. So I'm going to kind of jump to 12. They say find any equation that can't be factored and solve it using the quadratic formula. So in a second, I have to solve this guy using the quadratic formula, but I want to do the factoring problems first. So this is one I cannot factor, so I'm going to have to use quadratic. So if you can avoid using quadratic, it's usually easier to avoid using quadratic, is the kind of the strategy of this, right? Can we do a, does it have a perfect square that we can do a square root property with? Do the square root property with those, right? The next thing that we're looking at is factoring. Can we factor things? So here, do I have something that adds to minus, or multiplies to minus 15, adds to 14? And 1 and 15 would be what? Minus 1. We'll do it. So this is my 3x squared plus 14x minus 5 is equal to 0. So I want to break this thing apart into 3x squared minus 1x plus 15x minus 5 is equal to 0. So I'm grouping and factoring, doing the AC method on this guy. Between 3x squared and minus 1x, I can pull out an x, and that will leave me with 3x minus 1. Between these, I can pull out 5, and that should leave me with 3x minus 1. What I'm getting here is a 3x minus 1 and an x plus 5 are equal to 0. So either 3x minus 1 is equal to 0 or x plus 5 is equal to 0. So 3x is equal to 1, or x is equal to 1/3, or x is equal to minus 5. So this is doing the AC method like we did, doing the zero product rule, solving these things for x. So we got this one taken care of. This next one, we don't even know if we can factor it yet. So we have to look, we have to see if it's factorable. So let's look. How would you do this? So if these were a perfect square, you could probably do that. But we want to solve this by factoring. So we're not doing a square root property. So if we're not doing that, we have to get the side equal to 0. 5 minus x and 2 minus x. I have to do some distribution before I do factoring here. So this is 10 minus 5x minus 2x plus x squared, and this is equal to 4. So I'm probably going to do 2 steps at once. I want to subtract 4, so this should give me 6. This is minus 5 and minus 2 should give me minus 7x plus x squared, and this is equal to 0. So I'm going to flip things around. X squared minus 7x plus 6 is equal to 0. Put it in the right order. So I'm looking for 2 things. Now I can factor this. It's in standard form. I can do the AC method. 1 times 6 gives me 6. And I'm looking for things that multiply 6, add to minus 7. That's going to be minus 1 and a minus 6. So this thing factors, I can factor it straight using that shortcut. Into x minus 1, x minus 6 equals 0. So if it factors, factor it. It is going to be shorter than doing the quadratic formula, right? And so this is x minus 1 is 0. It's going to give me x equals 1. X minus 6 equals 0. Gives me x equals 6. That is that one was solved by factoring. This next one, 6x equals 2x squared, it probably looks a little complicated, but it's a little bit easier than it looks if you just set it up right. So 2x squared, and I'm going to subtract the 6x over, and if I do that, I'm going to set one side equal to 0. So I'm subtracting 6x from both sides. And now if I'm looking at this, the first thing you do when you factor is you always look for a GCF. And if you take out a GCF from this thing, it becomes a lot easier, a lot quicker. So if I take out 2x, it's going to leave with an x minus a 3. And this is going to be equal to 0. So either 2x is equal to 0 or x minus 3 is equal to 0, in which case my x is 0 or x is equal to 3 are my two solutions. Okay. Okay, and then this one looks like 5 minus x, 2 minus x. Oh, man. So this one, you can solve by, I wouldn't even say you solve it by factoring. It's already there. 5 minus x, 2 minus x, and this is equal to 0. It's already factored. You can just set these equal to 0. So the factors are a little bit backwards from what we usually solve them, but it's still factored. If you do this, you subtract a 5, a minus x equals a minus 5, or x is equal to 5. Same thing here, right? Minus x is equal to a minus 2 when we subtract the 2 over, or x is going to be a positive 2. And if we go plug back in 5 here, we're going to get a 0 here. If we go plug in back in 2, we're going to get a 0 there. It's going to make this a true statement. So you can go and check your solutions, or you can always go check your solutions, see if they make them a true statement. Okay. So we did that one by factoring, that one by factoring, we did this one by factoring, and we did this one by factoring. We got them almost all done except for 2 of them. So 0.1x squared plus 0.3x equals 2.8. Oh boy. So before I do anything, I don't want to do this with decimals. So if I multiply everything, every term by 10, or if I just move it over a decimal place, is another way of saying it, it's going to give me 1x squared plus 3x is equal to 28. And so this might be a little bit easier to solve than something with decimals. So if you have something with decimals, you can always try to get rid of the decimals. Multiplying everything by 10, same thing as saying everything moves over the decimal spot. So there are 1, 2, 3 terms I have to multiply. I multiply left side and right side together. Don't change things. So I want to see if I can factor this. In order to factor this, the first step to factoring is to set one side equal to 0. So hopefully you made it this far. Now I'm looking for something that multiplies to minus 28 and we'll add to 3. 1 and 28, 2 and 14. It's 4 and 6. 4 and 7, I mean, what am I saying? And it's got to multiply to minus 28 and add a 3. And the way we're doing that is with the 4 being negative and the 7 being positive. So I believe I can jump straight to those factors. This thing is 1 out in front now. So this looks like x minus 4 and x plus 7. So either x minus 4 is 0 or x plus 7 is 0, which means either my x is 4 or my x is a minus 7. And the last guy that I got to do. So this last guy, when we try to factor it, we could not find the factors. So this is the guy I'm going to have to plug into my quadratic. X equals a negative b plus or minus square root of b squared minus 4ac all over 2a. So my a is 2, my b is a minus 5 here, and my c is 7. So I'm plugging this information in. Negative of a negative 5 is a positive 5. So this is plus or minus. My b squared is a minus 5 squared. I do minus 4 times a times c. And divide this all over 2a, which is 2 times 2. This is 5 plus or minus root. This looks like 25. I have one negative here, so overall this is going to be minus 7 times 2 times 4 gives me 56 over 4. So I'm doing 25 minus 56 is giving me a minus 31. So this is 5 plus or minus root of a negative 31 over 4. $31 is not a pretty number. If you try to factor it, you're probably not going to find too many factors to factor into it because it's prime. It's only got 1 and 31. So we cannot simplify that thing a whole lot anymore. So 31 over 4. This is about as simplified as it's going to get. If you want to separate these things, you can absolutely separate these things. 5/4 plus I root 31 over 4 might be one way. If you really want to write it in a plus bi form, it looks like 5/4 plus or minus root 31 over 4 with an I out in front right there, maybe. But either of these three ways, if you wrote them on a test or something for me, I would be happy. They all look just about as pretty as one, and one's about as pretty as the other, or about as ugly. So that, I believe, is the last thing to do. They ask us another question. Solve the remaining questions. We solved them all. So that is the final equation. And we will do a little bit more practice over solving these things. All right, see y'all soon.